posted online. So we're going to do that now, and let's get started. Okay, number 8 on page 501 looks like this. We've got 2 cosine squared theta plus cosine theta minus 1 equal to 0, and we want to find the general solution equations and then the particular solutions between 0 and 2 pi today. So first thing we're going to do, slightly different approach maybe than some of the problems that we were looking at last week. We're going to need to factor this in order to solve for theta. We've got a polynomial here. You guys can factor by grouping if you like. Today, I'm not going to do it by grouping. I'm just going to go with cosine theta. But if you would prefer to change cosine theta into x and then factor that way, that works just as well. It looks like this is going to factor into +1 with the cosine theta and -1 with the 2 cosine theta. All right, so I've got this factored into 2 cosine theta minus 1 times the cosine theta plus 1. And now all that's left to do is to set each of these factors equal to 0 and solve for theta. All right, so our first factor tells us that the cosine of theta is equal to 1/2. Our second factor is going to tell us that the cosine of theta is equal to -1. And then our principal values are going to come from those inverse cosines. So our first principal value is coming from the inverse cosine of 1/2. So where on the unit circle in the first or the second quadrant is cosine 1/2? That is the angle pi/3. And then our second principal value is coming from where cosine is -1. So again, inverse cosine has a range in the first or the second quadrant. Where is cosine -1? Well, it's -1 at pi radians. So we're sticking with radians today. So we've got those principal values. The last thing we're going to do is we're going to use the general equations in order to write the general equations for this problem. So for cosine, both of these principal values came from inverse cosine. So we're going to use the cosine equations here. The cosine equations are always the principal value plus 2 pi n and the negative principal value plus 2 pi n. All right, so principal value here is pi/3 for our first factor. Set it up using the equations for cosine. And then I'm going to move over to that second principal value, continue our equations here. We're going to have, again, the principal value plus 2 pi n. And then we have the negative principal value plus 2 pi n. Now, if we look at equations 3 and 4, pi, if we look at pi on the unit circle, right, we're at 180 degrees, negative x-axis. Negative pi gets us to the same location on the unit circle. We'll just go a different direction. So pi and negative pi are coterminal, which means these equations are going to give us the same solutions. So we can actually just cross out theta 4, and we only need these 3 general solution equations as our final answer for part A. Right, second part of the question then asks us to find those particular solutions between 0 and 2 pi, inclusive of 0, exclusive of 2 pi, because again, those 2 angles are also coterminal on the unit circle. I'm just going to fill out the table. This is not something that you guys need to do. If you want to do it in your head, that's fine. But you are going to make sure that we always list our final solutions in order smallest to greatest. All right, when n is 0 in theta 1, we are going to get pi/3. When n is 1, we get 2 pi plus a positive angle that is greater than 2 pi, so we don't include that. Second equation, when n is 0, we get a negative answer, negative pi/3, so that doesn't fit between 0 and 2 pi. So then we move on. When n is 1, we get 2 pi plus negative pi/3. That's going to get us a total of 5 pi/3. Just do a mental check, you guys. Check for 2. Right, when n is 2, we get 4 pi plus negative pi/3. That's greater than 2 pi, so we don't have to worry about that. And then the last equation, when n is 0, we get pi, and when n is 1, we get something greater than 2 pi. So the final set of solutions, smallest to greatest, we've got pi/3, pi, and then 5 pi/3. Okay, those are we're gonna expand on those solutions on Wednesday's lecture, right, in the lecture video. But for now, we'll leave it like that. Okay, so slightly different than the problems we were looking at last week. Maybe you didn't need to factor in any of those problems to get theta by itself. All right, so one way we can do that, one strategy we use, factor. Number 10, slightly different. So number 10 is already in factored form for us. Don't have to do anything else, but we're going to see a couple of different things going on here. So part A, again, general solution equations. We're going to set each of those factors equal to 0 to solve for theta. So cotan plus 1 is equal to 0, and cosecant minus 1/2 is equal to 0. Okay, so we get two pieces of information here. The cotangent of theta is equal to -1, and the cosecant of theta is equal to 1/2. So our principal values, we've got two of them here. One of them comes from inverse cotan of -1. All right, so where is cotangent -1? Remember, cotangent has that range in the first or the second quadrant. So what angle in the first or the second quadrant yields a cotangent value that is -1? Well, there's only one, that is 3 pi over 4. So our first principal value comes from 3 pi over 4, that inverse cotangent. The second principal value here, we can do it one of two ways, okay? So we can say our principal value comes from the inverse cosecant of 1/2, or if you don't like looking at like values of cosecant and secant, that's fine. We can say that's also the same thing as saying the inverse sine of the reciprocal of 1/2, the inverse sine of 2. And in either of these cases, I'm going to take the sine case. We're looking for what angle has a sine value of 2. But remember, if we go back to the sine curve here, the min and the max of sine is 1, -1. Our sine curve is not going to go up to 2. The maximum for sine is only 1. So this actually doesn't yield a solution. But we do need to go back to that first principal value, and we need to write out our general solution equation. So that principal value, 3 pi over 4, that came from inverse cotan. So we're going to use the tangent equation to get our general solution equation. So for tangent, it's always the principal value plus pi n. And that's it. There's only one here. All right, last thing I'm going to do is I'm just going to list the the particular solutions between 0 and 2 pi. Since there's only one equation here, I'm not going to make a table. I'm just going to plug in values and do it in my head. So when n is 0, we get 3 pi over 4. When n is 1, we're going to get pi plus 3 pi over 4. We're going to get 7 pi over 4 there. And then when n is 2, we get something greater than 2 pi. So those are the two particular solutions that lie between 0 and 2 pi here. So a different strategy again, we didn't have to factor this one like we did for number 8, but we did see a case where one of those factors did not yield a solution. All right, stop me if you guys have any questions. We're moving on to number 14 now. So 14 looks like this. Take a second, write it out. All right, so two things. We need the general solution equations that make every single angle we plug in for theta make this equation equal true or be true. And then we need the particular solutions between 0 and 2 pi. So here we're looking for where 2 sine squared theta is equal to 3 times the quantity 1 minus cosine theta. So I'm going to do this in steps. I think the first thing a lot of people will do is they will probably distribute 3 into both of the terms on the right-hand side. But then we're here, and you've got to wonder where we're going from here. So we definitely want to get everything to one side. I'm going to do that last, though. The other thing is this. We don't have like common terms. We have essentially like an x and a y in our equation here. And that's going to be a problem if we need to factor something. So the first thing I'm going to do is I'm going to work on turning the sine squared into cosine. I want everything to be the same trig function. in order for us to be able to factor this. So I'm going to get it into like terms, and we can do that. We can turn sine squared into cosine squared using the Pythagorean identity. So sine squared is 1 minus cosine squared. And so that's what I'm going to do next. And that's going to allow me to move everything to one side and then factor what we have. So before I do that, I do need to distribute the 2 into both of these terms. 2 minus 2 cosine squared theta is equal to 3 minus 3 cosine theta. And I'm just going to move everything to the right-hand side. I'm going to make the coefficient of cosine squared positive because I don't like to factor anything with a leading coefficient that's negative. Just a preference. All right, so I'm going to get 2 cosine squareds on the right-hand side minus 3 cosine thetas, and then that's going to be plus 1. Now this becomes a problem like number 8, where we're going to factor in order to get to those principal values. Up to you guys how you want to factor. Factor by substitution if you'd like. I'm going to factor with cosine directly in my factors. It looks like this is going to be minus 1, minus 1. 2 cosine theta minus 1, cosine theta minus 1. We've got 2 factors. We can set each of those equal to 0 now and solve for theta. So 0 is equal to 2 cosine theta minus 1, or 0 is equal to the cosine of theta minus 1. All right, 2 principal values. One comes from the inverse cosine of 1/2. The other is going to come from the inverse cosine of 1. Inverse cosine of 1/2, what angle in the first or the second quadrant? Gives us a cosine value of 1/2, that is pi over 3. And then what angle gives us a cosine value of positive 1? That's 0, right? Always 0, not 2 pi. Okay. Got to be within the range of inverse cosine. Okay, write the general solution equations. Both of these are coming from inverse cosine. So we're going to use the cosine equations here. So principal value plus 2 pi n and negative principal value plus 2 pi n. Moving on to 0. Principal value plus 2 pi n, that's just 2 pi. And then negative principal value plus 2 pi n. Negative 0, not something we write. So these are the 3 general solution equations for this problem. All right, particular solutions between 0 and 2 pi. Do this however you'd like. I'll make a table for this because I've got a few equations to keep track of. And then we start. When n is 0 in theta 1, we get pi over 3. But when n is 1, we get 2 pi plus pi over 3, that's greater than 2 pi. When n is 0 in theta 2, we get negative pi over 3, that is outside 0 to 2 pi. When n is 1, we get 2 pi plus negative pi over 3, which gives us 5 pi over 3. I'm going to do just a really quick mental check when n is 2 there. That's 4 pi plus negative pi over 3, that's outside of 0 to 2 pi. And then lastly, theta 3, when n is 0, we get 0. Don't forget to list that, you guys. That's a valid solution. And then when n is 1, we get 2 pi, so that we exclude 2 pi, we include 0. List them in order, 0, pi over 3, and 5 pi over 3. That's the final solution set for part B. Okay.
So it can equal 0, but not. Oh, it's the same thing. Never mind. Got it.
Yeah, 0, 2 pi. They get you back to the same angle on the unit circle. So we only need to list 1, and we'll go with 0. Include 0, exclude 2 pi.
Got it.
so number 16 looks like this. We've got the cosine of 2 theta. This is equal to 2 minus 2 sine squared theta. We've got to figure out what theta is. So again, we have a similar issue where we have cosine and we have sine. So let's see if we can get everything down to like one single trig function, one common term, and then go from there. We can expand the cosine of 2 theta. There's actually 3 expansions for the cosine of 2 theta. Only one of those expansions gets everything in terms of sine or sine squared. So I'm going to choose to expand the cosine of 2 theta into 1 minus 2 sine squared theta. Okay? And the reason I'm doing that again is because there's a sine squared on the right-hand side. If it was cosine, I would probably choose the cosine option, right? The cosine expansion there. And then I'm going to move everything to one side. I'm going to get the common terms together, right? So I'm going to add 2 sine squared thetas to both sides. You can see what's going to happen next, right? You don't have to show that, but we get this. The sine squareds go away. We get 1 is equal to 2. Last time I checked, mathematically, 1 was not equal to 2. Right? Not true. We get a statement that is not true. Statement that is false. So this doesn't yield any solutions. Undefined. Right? So we leave it like that. Best type of problem. Don't have to write any general solutions, and then you don't have to find the particular solutions. Okay, I'm going to do 2 more problems with you. We're going to do 18, we're going to do 20. We're going to switch the order there. We're going to do 20 first, and then we're going to do 18. There's a reason why. I'm going to explain it to you. But this next concept that we talk about, you guys, if there's anything you're going to walk away with today, walk away with understanding this one. All right, so take a second, write number 20 down. We've got this. The sine of 2 theta is equal to the cosine of theta. We've got to figure out what the general solution equations are and then the particular solutions between 0 and 2 pi. Okay, so we've got the sine of 2 theta is equal to the cosine of theta. We've got to figure this out. Now, I'm going to first start by expanding the left-hand side. The sine of 2 theta, we can expand using those trig identities. That's going to become 2 sine theta cosine theta. Okay, next, you guys. I'm going to pause for a moment, and I would like you guys to think about where you would go from here. What is your next step? Before I show you it, what would you do?
Maybe square both sides and turn sine squared into 1 minus cosine squared.
Ooh, that's an interesting idea. I'll have to try that separately. That's not the way I'm going to go, but I'll try that after we get done. Say that one more time.
Could you subtract cosine theta from both sides and then factor it more?
Yes, yes, indeed. I should factor it more. Okay.
And wouldn't you have to keep track of it somewhere else?
What's up?
Well, I mean, I tried that on number 14, and I ended up just not getting one of the solutions when I did that. So
Yeah,
doesn't that
okay.
mean that we have to keep track of it?
Could you divide both sides by cosine?
These are really good ideas. Yes, so we're going to do that. Okay, so hang tight on those. One of those solutions is the way we're going to go. Not necessarily the only way, but I'm going to show you something first. So I can't see you guys. I can't see most of you guys, but I need everybody to put their pencil down right now. I'm going to trust that you're doing this. Put your pencil down. Do not write this, okay? I'm going to show you something, and then we're going to see what happens. So I think the first thing I'm going to do, again, pencil down, do not write this. I am going to divide everything by cosine. Okay, and what happens when I divide everything by cosine? Well, the cosines cancel on the left side and the right side, and we're left with this. 2 sine theta is equal to 1. Great. now we can get theta by itself, right? The sine of theta is equal to 1/2. Take the principal value there using inverse sine. All right, but here is the issue. When you divide to cancel in problems like this, you end up losing information. So I think Asher was the one that said that, right? We lose half of the information for this problem when you divide to cancel. So I'm going to go back and we're going to start this from the beginning again. You guys can pick up your pencils now. Okay, we were here. And I think it was, Etche, did you say that? Subtract cosine from both sides?
Yeah.
I can't see anybody, so I'm just going off of voices here, you guys. All right. We're going to subtract cosine for both sides, and then we're going to factor the cosine out of both of those terms. We have a common factor. Cosine is the common factor here. So when I pull a cosine out of both of those terms, we're left with cosine theta times 2 sine theta minus 1. And then we do the same thing we've been doing for the other problems. We set each of the factors equal to 0. Cosine theta is a factor. And then 2 sine theta minus 1 equal to 0. So remember, when I did it and you guys had your pencils down, the only thing we had was this one. We lost the information related to the cosine of theta minus 0 when we divided and canceled. So here's what I need you guys to do. On your paper somewhere where you're going to see this on your test in big capital letters. You're going to write, don't divide to cancel. We lose information when we cancel things out. Okay. So take a second, write that out, and we'll finish this problem. Okay. I'm going to tell you guys a story really fast. I don't know how well it's going to go over on Zoom, but someone once told me, imagine the cutest, fluffiest thing, okay? Like an animal, like a super cute, fluffy animal. Let's go with like a puppy corgi, okay? Imagine a puppy corgi. Anytime you divide and cancel, anytime you're solving a problem like this and you divide and cancel, imagine that a cute puppy corgi dies somewhere in the world if you divide and cancel. So don't divide to cancel, save the cute puppy corgis. Hopefully you won't forget now.
My dad tells me that, except with giraffes.
Oh, I don't know what's more sad. Okay, just don't do it. Don't do it, you guys. All right, just say no. Okay, let's do this. The principal value here comes from inverse cosine. And then the principal value here comes from inverse sine. Right? I definitely skipped some algebraic steps there. So if you need me to go through those with you, let me know. Inverse cosine of 0, where is cosine 0? Cosine 0 at pi over 2. So where sine is positive 1. And then where is sine 1/2? Sine is 1/2 of pi over 6. So we are going to have 2 equations for each principal value we found. Now here's the deal. We also have a mix of factors. We have one factor that gave us a principal value coming from inverse cosine. The other one gave us a value coming from inverse sine. So the first set of equations for that principal value pi over 2, we need to use the cosine equations for. The second principal value pi over 6, we need to use the sine equations for. So be really careful about that. I see that as a common mistake often on the test for this unit. Just make sure you guys look at where those principal values are coming from and you're using the correct equations. So for cosine first, it's always the principal value plus 2 pi n. And then the second equation is always the negative principal value plus 2 pi n. Right, so that comes from the inverse cosine of 0. We're using cosine there, we're using inverse cosine, so we're going to use the cosine equations. And then the second set of solution or general solution equations here comes from inverse sine. So we need to use the sine equations. That is the principal value plus 2 pi n. And then the second equation is pi minus the principal value. So pi minus pi over 6 is 5 pi over 6 plus 2 pi n. So this one actually gives us 4 equations. None of them are the same. Be really careful about 1 and 2. They are different. Pi over 2 is 90 degrees. And negative pi over 2 is 270. All right, so different places on the unit circle, we can't cancel those out. Those are different. And then we're looking for the general or the particular solutions between 0 and 2 pi. All right, inclusive of 0, exclusive of 2 pi. Here we go. So again, really quickly, going back, when you killed that puppy corgi or the giraffe, right, we were losing all of this information because we divided to cancel. So don't divide to cancel there. Okay, I'm going to start with 0, 1. You can always add more if we need. Theta 1, when n is 0, we get pi over 2, and then there's not going to be a solution when n is 1. 4, theta 2, when n is 0, we get a negative value, so that doesn't work. But when n is 1, we're going to get 3 pi over 2. Theta 3, when n is 0, we get pi over 6. And then when n is 1, we get 2 pi plus a positive angle. It's greater than 2 pi. Doesn't work. And then the last equation, theta 4, when n is 0, we get 5 pi over 6. And when n is 1, we get 2 pi plus a positive angle, which doesn't yield a solution. So 4 answers here. We're going to label them smallest, or we're going to list them smallest to largest. Okay, so pi over 6, pi over 2, 5 pi over 6, and then 3 pi over 2, I think. Yes. Again, table, you guys don't need to show. If you can do what's boxed in orange in your head, that's fine, but I do need to see the work algebraically for part A. And don't divide to cancel. Okay, last problem I'm going to work you guys through, and then you guys will just finish the evens on your own. Number 18, so we're going to go back. 20 is the last problem you have to get through, so you're doing the odds up to 20. Cosine theta plus sine theta is equal to 0. There's a reason I'm doing this second. Okay, here's how I'm going to approach number 18. Right, I'll explain why in just a minute, but I'm going to subtract cosine from both sides. You actually don't need to do this step, but first, you can do it last, but I'm going to do it first. Okay, so I'm going to subtract cosine from both sides. I get sine theta is equal to negative cosine theta. Okay, now look at this, right? You're like, what are we going to do? Can't divide to cancel. However, if you divide and you don't cancel, that is legal. That's okay. So that's how we're going to approach this problem. I'm going to divide both sides by cosine. And I can do that because cosine doesn't cancel, right? There's no cosine in the numerator to cancel with. Cosine doesn't cancel. It gets absorbed and it turns into tangent. So on the right hand or left hand side, right? Sine over cosine, tangent, using that quotient property, is now equal to -1. So we can't divide to cancel. Don't divide to cancel. But we can turn into tangents. Or cotangents. Right? The cosine didn't get canceled out on the left. It turned into tangent, got absorbed, still there, didn't disappear. So we're not losing information this time. All right, and now our principal value comes from the inverse tangent of -1 in the first or the fourth quadrant. Where is tangent -1? Well, at -pi/4. Tangent only yields one equation here, which is really nice. We like working with tangent. negative pi over 4 plus pi n. Pi n, please don't forget that, not 2 pi n. Period of tan and cotan, just pi. And then the second part, you guys, I'm not going to make a table for this one. There's only one equation, so I'm just going to do everything in my head. When n is 0, we get negative pi over 4. That does not work. We don't include that. So I move on. When n is 1, I get pi plus negative pi over 4. That is going to be 3 pi over 4. That's when n is 1. Right? And when n is 2, I get 2 pi plus negative pi over 4. That's 7 pi over 4. That's between 0 and 2 pi still. But if I were to go further, if I were to look at n as 3, I'd get 3 pi plus negative pi over 4. Doesn't work outside of 0 to 2 pi. Final answer there, 3 pi over 4 and 7 pi over 4.